Hello everybody, with you Dr. Nahed. Today I'm explaining for you section 6.1 Indefinite Integer and Business Mathematics BU6013. Through this session, we will discuss the following objectives. First, recognize the notion of indefinite integration and write down the integral of simple power function. Also, we have to integrate function of the form a of x plus bgx and to calculate the cost function if any marginal cost function is given. Also, the same thing for the total revenue if the marginal revenue function is given. Also, we have to find the consumption and saving function given either the marginal propensity to consume or marginal propensity to save. What is integration? Integration in calculus is just the inverse process of differentiation. So we call it integration. It is the opposite of differentiation. So if we have a function f capital X which is differentiated to get the small function of x, therefore by integration we can get back the original function. Okay, if f dash x is equal to f x, then the capital Fx is said to be the integral. Okay, or sometimes it's called the antiderivative or primitive of function fx, which can be written as a symbol fx. With this symbol we call it integrate small fx dx, so with respect to dx, which we can read it integral of fx dx. Giving an example, we know that if we differentiate x to the power 3, we will get 3x squared as the first derivative, which means that the integration of 3x squared will give us x cubed. But we have to recall that it could be not only this one, it could be also fx equal x to the power 3 plus 5 or any plus other constant, because the differentiation of any constants will be just 0. So it will be also the same thing. If we have plus 5 or plus 2, if we differentiate it with respect with x, we will get 3x squared. So we have to recall that if we have integrate fx dx, the resulting function will be capital Fx plus c plus constant. So that always we will have to get plus constant. The first integration rule we will discuss is the power rule. When we have x to the power n, the resulting will be x to the power n plus 1 over n plus 1, okay, plus c, because we have always to add the constant, because the integration of constants, the differentiation of constants is just 0. This valid for any n except n minus 1, because we cannot divide over 0. So we have the special case for if we have n equal to minus 1, which is the integration of 1 over x dx, which will be lnx+c. So this is a special case that we can have when n is equal to minus 1. So let us take an example. Also, for integration rule, if we have sum and differentiate, as we have in differentiation, we have also for the for integration. If we have the integral for a of x plus bgx dx, so we just can take the constant out of the integral and we can integrate the function of x plus b integration of gx dx. This can be valid for the sum, also for the. Let us do the first example. They will ask us here to find the integral of x to the power 60x. So we have here power 6. According to the rule we are applying, the result will be x to the power n plus 1 and we have to divide also over n plus 1, and we have to keep plus c, do not forget it. C. Okay, so according to this, here we have the power 6, so x to the power 6 plus 1 will be 7, so x to the power 7 over 7 plus c. So we get it, so it will be x to the power 7, and we have to divide over 7 as well, plus c, applying the rules that we discuss. Here we have x to the power 2. We don't have any rule for x to the power 2. What we have is just for the integration for x to the power n. So in this case, we have to put x squared in the form of x to the power n, so it will be x to the power minus 2. Now, our n is minus 2. Minus 2 plus 1 will be x to the power minus 1. So we have to divide over minus 1 as well. And do not forget writing plus c. And we can take x minus 1 back down again to make it as positive power. For the last one, we know that the square root is just the power half. We have to recall that the square root is just the power half, x to the power half. So our n is, in this case, is half. Half plus 1, it will be 3 over 2. So we have to divide also over 3 over 2. By simplifying, 3 over 2, the denominator will come a numerator. So it will be 2 over 3 x to the power 3 over 2 plus the constant, which is always, if we have indefinite integration, we have to add it. Now you have to pause the video and try to answer these questions. The answer will be as shown. The first one, we have x to the power 4. So it will be 4 plus 1, it will be 5. So we have to divide over 5 plus c. Also, same thing for the second one, but we have to be careful that we have here x to the power 3 down, so it will be x to the power minus 3 first before differentiation. So our n is minus 3 plus 1 will be minus 2, so it will be x minus 2 in the top, and we have to divide over minus 2, so it will be, so the integration of it will be, okay, it will be x to the power minus 2 over minus 2, and we can take x to the power minus 2 down, so it will be x positive, as shown here. Okay. Same thing here, we have the n will be 1 over third, 1 over third plus 1, so it will be 4 over 3 over 4 over 3, so we can be, so it will be 3 over 4 x to the power 4 over 3 plus c. The difference, so here we have to consider it as x to the power 0, so it will be the difference, it will be the integration of 1 is just x, okay, plus c, while integration of x to the power 1 here, so the power here for x to the power, here it will be power 1, 1 plus 1 will be 2, so it will be x squared over 2 plus c. And if this is the special case when x power minus 1, so it's actually ln x, so it will be ln x plus c, which is the special case when n is equal to minus 1. So this is the solution as shown. Moving forward for if we have a combination of plus or minus with a constant as well. So what we have to do here, this integration, it's actually the integration of the first term of x squared and also the integration of the second term with negative in between of them. So actually, we have to integrate the first part. So it will be x squared. So n is 2. So 2 plus 1 it will be 3. So it will be x to the power 3 over 3. And just keep 2 in front. Same thing with the second part. We have minus 4, just keep it alone. And we have here x to the power 6, which will be 6 plus 1. So it will be 7 over 7. And we have to add the c at the end. Okay, for the second one, same thing. We have to integrate the first term, x to the power 3 over 2, plus 1, which will be 5 over 2, divided over 5 over 2. Here just should be 5, my dear. Okay? It should be 5 here instead. Okay, and here we have 2, and we know that 1 over x, the derivative, the integration of it is just ln x. So we just have to keep 2 in front. Okay, and we have to simplify. So 2 can be the denominator of the denominator will be a numerator, so it will be up, and over should be over 5. So it should be here instead of 3 should be 5. For the last one, we have to do the same thing with the 3 terms as we have. So 5 in front, x to the power 3 over 3, plus 3 x squared over 2, and plus 2 the times x. So we will have 2x plus c. Now, I want you to pause the video and do this exercise by yourself. Then continue. The solution will be by integrating the x and multiply it with 2. As we know, the integration of x will be x squared over 2. And so therefore the 2 with 2 will be cancelled as shown here. So the 2 and 2 will be cancelled. So it will remain just only, remain only x squared. So we got here only x squared because it will be 2 over 2. So we have here 2 and here 2, which will be cancelled with this one. So we remain with x squared only. For 4x to the power 3, 3 plus 1 will be 4 divided by 4, but the 4 will be cancelled with 4. So we have here the 3 will be 4, and we have to divide over 4. So the 4 will be cancelled with the other 4, which is in front. So we'll remain with only x to the power 4. And we have to add the c in all cases. For the second one, x to the power 4 will be x to the power 5 over 5. The 5 with 10 will be 10 over 5 will be remaining just 2. Same thing for the x squared. We have to take it first. Take the x squared to the top with minus 2 plus 1, so it will be power minus x, which so we can take it down. So it will be minus 5 over x plus c. And the same thing for the last one. So it will be as shown. So it will be x to the power 3 over 3, and here 3x squared over 2, and plus 2x plus c as shown here. Indefinite versus definite integrals. What we discuss in this session, which is called indefinite integral, while definite integral we will discuss it later on in 6.2. as application of indefinite integral, we have the marginal. So when we get the marginal revenue, we can, which is the first derivative of the total revenue, we can integrate the marginal revenue to get the total revenue. And also, if we have the marginal cost, we can integrate it to get the total cost. And same thing for the others function as shown here. Okay, so but we have, as we know that we will have a constant with each one. So to get the constants in this case, we have to keep that always that the total revenue at 0 will be 0, and the total cost at 0 will be the fixed cost, which will be our C in this case. So let us take example to make it more clear. Here they are giving us the marginal of cost function given by q squared plus 2q plus 4. Once we get here marginal cost, so we can integrate this function to get the total cost. So just by integration, we can get back to the cost. Okay, so we have to integrate the marginal cost with respect to dq. So the integration of q squared, so 2 plus 1 will be 3 divided by 3. The 2q squared, so it will be just q squared, and integration of 4, which means that q to the power 0, so it will be q to the power 1, so it will be 4q. And we have to add c. In this case, we have to put the total cost at 0 will be the the fixed cost, which is 100. So in this case, if we substitute with 0, q at 0, we will get 1/3 times 0 cube plus 0 cube plus 4 times 0, which plus c equal to 100. So that means in this case that the c will be exactly 100. So the c will be actually the fixed cost will be equal to the c. Taking the example 3 here, they are giving us the marginal revenue. And once we get the marginal revenue, to get the total revenue, so we have to integrate both sides with respect with dq, so to get the total revenue. So what means that the total revenue will be just the integration of marginal revenue with respect to dq. So what we will have, the integration of 10 will be just 10q. The integration of 4q squared, so it will be q squared, sorry, the 4q will be q squared over 2. So the 2 will be cancelled with 2, and in that case it will be just 2q squared as a result. And we don't forget to add constant. And to get this value of constant, so we have to set that the total revenue at q0 will be just 0. So we have to substitute with the q0 here and here. So it will be tr0 equal to 0, which lead us to lead us that c is also equal to 0. So the total revenue will be 100q minus 2q squared, only because c just goes to 0. Now they are asking also to find the demand function. We know that the total revenue is just b times a q. So what we have here is just b times a q. So we can take q as a common factor or divide by q, in another word, to get just the b. So what we do, just we have to divide over q both sides. So what we will get here, if we divide over q, so it will be 10q over q will be just 10, and 2q squared over q will be 2q, because this q is common for both numerator. so which results as 10 minus 2q squared, or just take a q as a common factor. So this will be our p. So also here we have the marginal probability for consumption. So if we just integrate it, we will get the consumption function. But here we have to see to keep in our mind that the root of y square is just y to power half, and it's down, so we have to take it with negative to power half in the top. Okay, so let us start. So it will be just the integration of marginal propensity to the consumption function. So we have to integrate 0.5 plus 0.1, and we just keep y to power half down, so we will take it up, so it will be y to power minus half d with respect, we have to integrate it with respect to y. Integration of 0.5, so it will be just 0.5 y, and here we have to add 0 minus 0.5, we have to add 1 and divide, so it will be 0.5 over 0.5, and we can simplify it, and do not forget to add the 0 as well. So this is what we got here, 0.5 y. For this one, it will be 0.5 y. Here we have to add 1, so it will be 0.5 over 0.5, and we have here 0.1 divided by 0.5 will be 0.2, and y to power half is just the square root of y plus c. To calculate c, we have the given consumption function is 85, so that c is, so we got c with 85 when the y, which is the income, is 100. So y is 100, we get c 85, so we have to substitute in our formula with these. So what we will get, y equal 100, the capital C is 85, we have to calculate the small c, or the small constant here. So just by substituting in the formula, we can get, we have to add it using the calculator, then subtract it from the 85, we will get AC is equal to 33. So we can just write that the cost function, or sorry, the consumption function will be 0.5y plus 0.2 root of y plus 33 as a final result. Now you can pause the video and do this exercise by yourself. So here, the first one, they are asking you to find the cost function. If the marginal cost is 2, so you have to just integrate 2 and substitute with the fixed cost equal to 500. If the total cost product is 40, so you have to substitute in the formula to calculate the cost, the fixed cost. And same thing for if you have the marginal revenue function, you have to integrate it to get the total revenue and substitute with TR equal to 0 at Q is 0. And same thing for marginal propensity for saving, you have to integrate it and with respect to y, and to get the saving function, then you can use the information given in substitution. So it ends up to find the answer as shown here. As a summary, if we have the consumption function, by differentiation we are reaching the MBC, and if we integrate it, we are going back to the consumption function, and the same thing for the saving function. From the saving function, if we differentiate, we will get the MBS, and if we integrate, we will go back for the saving function. And keep in your mind that the consumption function and saving function is equal the national income, and both MBC and MBS give us giving us 1. Also, if we have the average revenue, if we multiply it with quantity, we are getting the total revenue, and if we divide over the quantity, we are getting the average revenue. Also, if we have total revenue, if we multiply it, if we want to calculate the total revenue, if we have the demand, we have to multiply it with the Q. So the arrow should be opposite. B times Q giving us the total revenue, and if we divide the total revenue by Q, we're getting back for the demand. So it will be, the arrow is here, is opposite, if you can realize. Okay, and if we get the total revenue and differentiate it, we will get the marginal revenue. But if they're giving us the marginal revenue, so we can go back for the total revenue by integration. Same thing for the average cost and marginal cost, and also for the others function. This is the summary which will give you the full vision of what we discussed today. Thank you, and do the exercises that is in your Moodle page.